In particular, visible light is in this narrow region of the spectrum where the wavelength, or the distance from trough to trough, is about 10 to the negative 7 meters. Atoms, on the other hand, are much, much smaller, and the interatomic separation is about 10 to the negative 10 meters. So in some ways, visible light is simply too big to look at atoms. You can think of it as like, if you were trying to figure out the shape of a single grain of sand using your fingertips. And so clearly, we need something smaller. Well, fortunately, we have a spectrum, so maybe we can choose radiation of shorter wavelengths. In particular, there's a region of the electromagnetic spectrum that has X-rays, whose wavelengths are on the same order of magnitude as the interatomic separation. So in this class, we'll be looking at how X-ray diffraction can be used to study atomic structure. Thank you.
Time.
Oh man, mic drop, man. Enze, where did you learn how to teach so well?
Well, thank you for the compliment. I guess it's not kind of fair. I was a TA in my undergrad for a few classes.
Oh, okay, all right. I am blown away. That is so good. Your whole style, everything about it. Wait, leave that slide up for a second. First of all,
okay.
All right. I see a big thumbs up from, yeah, that was great. That was beautiful. That was just great. I'm smiling because I'm like, I cannot think of anything to critique on that. You were so comfortable, the whole voice, the way you presented it, you were just so at ease. It was really very, very professional. And you said, I'm going to teach you something that kind of drew everybody in. You told us your name in a crystal clear way, a way to remember it. And then you went into the example that you made an analogy with the shape of a grain of sand, and you set it up perfectly. I was kind of thinking, I was a little worried that you're going to run out of time, but you covered it all, and you were super. I knew you knew you were going to land on spike that 2-minute mark. That was amazing. Yes. Other comments from anyone else?
I wanted to say, in the beginning, this is a topic I'm actually familiar with, and I was just like, how's he going to explain it in 2 minutes? And when it was like time and he was still on the right side of the electromagnetic spectrum, I was just like, how is this going to end? And I was just super impressed with how like the hook left everyone hanging in a way that like made the topic really engaging.
Thanks, Salim. And thank you for timing as well.
You did it. You did it. Okay, that was really, really good. And I would have to say the other thing I like about is the name and the handwriting. Let me come back to names again. I'll send you guys. I meant to send it. There was an article in the New York Times about this weekend. Roxane Gay was responding. She has a column, and she was saying about you have the right to be, to people to get your name right. And it was a really interesting perspective. And I wanted to share it with you because I think names are really important. And I find that in a lot of times students, especially with complicated names, will kind of gloss over them. And just because they're a little uncomfortable, there've been people not learned their name in the past, and they kind of don't want to, think about it. But I would say take the time to really get that right and really share with people how to say your name. Slow down, give them a clue like NZ, right? He just said NZ. That was really helpful because they actually could pronounce that different ways. But once he said that, now I know it. I'll remember it. And I'll remember him, right? I mean, so, it's nice to be able to just take that moment and let people hear your name and really get that because you want them to be able to address you, okay? So it's worth the time. And you took, a good fraction of your talk to tell us your name and made it really clear. And that was a great use of the time. So
thanks. That was actually the first time I think I've ever done that. So
really?
I appreciate
That's really interesting. Okay. Yeah. No, and everybody, by the way, if you didn't do that at the beginning of your class in your GSI this semester, fine, you can do it anytime. Just come in and say, by the way, I just want to clarify, my name is this, write it out, give them some kind of phonetics, maybe an easy way to remember it, or some nickname that you want to be used. There's lots of different ways to do that, but names are important. And yeah, take that time. All right, so let's go on to Yuhang. And are you ready, Yuhang?
Yep.
Okay.
Let me share my screen.
And Professor Goldberg, I will be in charge of giving critique, or should I still?
Yes, actually, yeah, thanks for reminding me. Good. MJ, you're going to give the critique after this. Good.
Okay.
So can you guys see my screen?
Yep.
Blank.
Yes.
Okay.
Yes. All right. And tell me you're going to do this the time again for us, okay?
Okay. I'm sorry. Who will?
Just let me know when you're gonna start.
Okay. Okay. Let's start. So hello everyone. I will be your GSI, and my name is Yu Han, Yuhang, and my last name is Cai Kai. You can call me Yu Han, and the topic that I will talk about today is it's not a specific problem. I want to talk about a picture that we use in material science. The picture. I will draw the picture as a tetrahedral. This is what I learned from another class. I think it's very helpful for material science and engineering study. As our name suggests, material science and engineering, we study the material science and we apply the science into engineering. So for engineering, we need the performance of some specific materials. So here we have performance. For example, we have a tool, we have a technique, we have a instrument. So we need a performance. So what do we need if we want to have a good performance? First, you need to have a
30 seconds.
You need to have a material with a good property, and you need to process the material into a realistic device. And what determines the property is, of course, the structure of the material. So basically, the intuition here is if you want to realize any one of the 4 elements, you can link it to the other 3 elements. Yeah, that's all. Thank you.
Oh, good. Okay. All right. Enzi.
Yeah, so great talk, Yuhang. I really like the fact that you had a picture. This was actually a very realistic 3D structure of a tetrahedron. I'm not sure if I could draw comparable structures. I think this could be a personal thing, but I might have preferred the motivation behind why you were drawing the picture before you drew the picture. I think you drew the tetrahedron, didn't label it, and then explained how, oh, in material science we have, these ideas that we're working with. And you didn't have to say the 4 words, but just maybe kind of a build up into how we can think, oh, what's a good mental model for the things we care about in material science? Maybe a tetrahedron. But the flip side could be, I guess, finishing off the sandwich could be, oh, it did leave me, I guess, wanting more. When you put up a blank tetrahedron, I was like, oh, how is he going to fill this out? Are there going to be more tetrahedrons? And at the very end, when you sort of mention how, these 4 things are all sort of integrally connected, the tetrahedron really helped drive that point home. And it left me very satisfied at the end. So thank you.
Okay. I want to comment on the elements inside the sandwich. Actually, it can be something like if you have any other element. Because in this case, I don't want to spend too much time on that. So in other cases, if you have like the 5th element, you can draw something like this. So the 5 elements are connected with each other. So and maybe I don't understand your question quite well. Can you repeat it again? So your question is why I first draw the tetrahedron.
So let me jump in. So a couple of things here I want to say. So this is a good situation where you were doing two things, I think, really well, Johan. You were asking him to clarify the question, but you're also getting a little defensive, right? So here's what I would say is, in this case, you try to take in the information, and in some sense, I think that the idea, the critique, if you will, was just that it would be helpful to understand a little more about the context before you went into the drawing, right? And that's all he was saying, because I think that if you re-listen to it, and actually this one nice thing about the recording, by the way, you guys can go back and watch your own talk, which is a really nice feature, and you can, you'll be able to look at it and then just think about how you might do it differently. Let me just mention really quickly on one thing, which is another point to keep in mind. When a student asks a question, always look at it as a positive. In other words, they're not criticizing you when they're asking a question. And I think it's a very common response, which is, wait a second, I explained this clearly. Let me see, here's why I explained it this way. Try not to do that. Just try to accept it and then say, how could I have improved it? In other words, don't try and defend your way, but accept it and change and say, here's another way of looking at it, right? So I want everybody to have that kind of mentality. I'll try to do it too. But when you hear somebody come in and say something, they're basically saying, you know, here, I'm not getting this. So here, how can this be done differently? And then just take it from that view of, let's think about how I could do that a different way. And don't spend time trying to explain why you did it the first way. It's just not, it doesn't really help, because now you're getting into a tension between you and the asker, as though, you know, you were right, they were wrong. You know, you don't want to do that. Just say, oh, that's an opportunity for me to think another way. And there's always, as everybody knows, so many different ways of explaining anything. Okay, so use that as a trigger to say, I'm going to go on to another way. Let me say this. We're now at 6:30, and I have a suggestion. I'm thinking that it might be good for us to do the following, which is anybody who is, what I'm going to do is I'm going to break out into breakout rooms for, I'm going to give you, let's say, because of 2 minutes each, I'm just thinking, I'm trying to do the math here. I'm going to give you 8 minutes in breakout rooms, and I'm going to do this anonymously. Randomly. Now, what that means is, if you want to take off for the day, and you already did your 2-minute lecture, then you can just take off and call it a day. And if you wanted to stick around, another option is that you could stay in the main room with me, and we can talk a little more about general principles, and we can stick around if anybody is still here after we do this. But what I'm going to do is send you off into these breakouts. Actually, let's just make it 10 minutes. And that way, what I'd like you to do is, if you're in with somebody else who hasn't gone yet, for you each to take turns, time each other, give each other feedback, and then come back into the room, the main room, in 10 minutes, and then we'll share a couple of the things that you've learned. Does that sound reasonable? Okay, so I'm trying to do this on the fly, and I'm not an expert on this one. I'm going to just do breakout rooms. So here's the rule again. If you find yourself in a breakout room with somebody else who hasn't presented yet, then you guys both do your presentations together. Okay? Or if you've done your presentation, the other person hasn't, let them go, and then you guys could just shoot the breeze a little bit. All right? Or if you really don't feel like doing that, come back into the main room, and then I'll try and keep track, and I'll reassign someone else into the breakout room with you. Okay? So you'll get somebody else. There should be a better way to do this, but I'm just going to try to wing it. All right, and then those who stick around and are still here, we'll shoot the breeze a little bit too. Okay? Good. So just stand by. I'm going to try this. I'm going to try and break you into 15 rooms. Whoops. So there's 29 people here. Let's say 14 rooms, and it's automatically. All right, let's see what happens. Okay. So Tanya, are you there? Ming? Tatiana, I'm sorry. Meng. Okay, Meng is here. Meng, have you presented yet? Oh, Meng isn't speaking. Okay. Hi, Zinab.
Hi. Actually, nobody was in the breaking room.
Oh, okay. That's what I was afraid of. Okay, I'm sorry. Okay, it's funny. It doesn't show me that, but that's good. Okay. Do you want to do a practice just with me? You can do that?
Yeah, sure. Yeah.
Okay.
I can share my screen. Basically, because you had two accounts, I guess. I was with you with your another account, the one that doesn't have any video.
Oh, okay. That sounds
Yeah.
fine. Okay.
So, hi, I'm Zinab Jadidi. You can call me Zinab. So today I want to talk about how we can use a lithium-ion battery to power a device. So in general, a battery consists of three main components. So the first component is called anode, which is a negative electrolyte. I'll show it with a capital A. The second component called electrolyte, which is an ionic conductor, and I show it with capital E. And the third component is called cathode, which is a positive electrolyte, which I show it with capital C. So when we place a battery in a device, a lithium-ion batteries actually moves from anode to the cathode like this. So here the dots is I represent the lithium ion with the little dots. So what happens is that the cathode will be bombarded with positively lithium ions, which will make them a positively charged than the anode. So what happens is that electron, which has a negative charge, is going to attract to our cathode. Once the electrons starts moving towards cathode, we can force the electrons to go through our device, which then it can actually charge our lithium-ion battery. So next time I can talk more about how we can actually use lithium-ion battery to recharge it again and reuse it again. So yeah.
Very good. Okay, right on time. Excuse me.
Are you okay?
Yeah, I'm fine. I'm fine. I just drank some water that was went down the wrong pipe. All right,
Okay.
Zinab, this is great. Couple quick thoughts. One is it was really good that you explained your name. Is there any anything you could do on your name that might give them a little better way to remember it? Like are you teaching, by the way, this semester?
No, not this semester. Yeah.
Okay, you will in the future. Okay.
Yes. Yeah.
So is there any way you could give them a little something? Like, I'm always thinking of, it's a beautiful name, by the way, but I'm just thinking about how can you, like, it means something in some other language, or, what does it mean? Do you know?
So I know the meaning. Basically, it's I think the root is Arabic name.
Okay.
It's called it consists of Zain plus Ab. So Ab in Arabic means father, and Zain in Arabic means glorious and beauty.
Oh, that's really interesting.
Yeah.
So you might say that,
Oh, okay.
beautiful father, right? Or something, right? And I think that that's really helpful. It gives people, you taught them something interesting, right? That father, Ab is father, right?
I see.
And that Zinab, Zin means beauty, Do you know what I'm saying? And you
Yeah,
could
yeah.
break that down, and then all of a sudden, you're sharing with them a little bit of your culture and a little bit of where it's coming from, and then you read it a different way, because now I see it as Zinab, as the two parts.
Yeah, okay.
So think about that.
Sure.
The other thing I was going to say, excuse me, about lithium is so interesting, because you could, for example, start by saying, today almost every one of our phones and laptops is powered by a lithium battery. And why is that? In the past, there were other, what was it, copper or other kinds of batteries were used?
The one in industry, the main one I know is lithium-ion battery. I don't know the older ones. I don't have much information.
One thing would be interesting, if I were just going down this rabbit hole for a second, but you might go to Wikipedia or something and just look up lithium ion, and in the history section, it'll tell you when it was invented and what's the, because you can say that, it's fun to give a context and say, this battery is used all over the world now, but it was only invented in 1975. And I want to show you why that lithium has been such an advantage, right?
Sure. Okay.
And then the other thing that I'm kind of curious about is, why it works so well, right? Why it's able to charge so often. And then there's all these questions. I'm always fascinated by, like, how a real battery in your phone or your laptop actually has lots of different cells, right?
I see. Okay.
So you could add those back. You could say, so there's really interesting questions about the algorithms for how you charge these lithium batteries, right?
Okay.
And just give us a little glimpse of where that's going. Anyway,
Sure.
It's great, and I think it's a really good topic to choose. What's your department?
Material science.
Good, material science. Right. I know it's a big effort to try and find the next lithium, right?
Yeah, actually, my research is on lithium-ion battery.
Okay. All right. Great. Beautiful. All right. Thank you. Okay. Good. So I see people coming back. They already finished their evaluations. Yeah,
I already went with Johan. He was the one that was critiquing my presentation, basically.
Okay.
He can let you know how it went, I guess. But that's what I went through.
Okay. Oh, you're talking about the photoelectric effect.
Yeah. Einstein stuff.
Yeah, it was Albert Einstein, right? That was his first thing, right?
Yeah, he's like the one that he won the Nobel Prize for.
Well, I wouldn't say it's his first thing. It was one of 5 things that happened at the same time.
Yeah, he did many things at the same time.
That was a great year for him.
Yeah, he won the Nobel Prize for this. That's his work for this. Yeah.
Right.
But I don't know how he felt about the Nobel Prize for this, because I feel like he was probably more proud of relativity and was just like,
yeah.
He should have gotten Nobel.
He only got 1, right? He didn't get 2.
Yeah, he only got
That's
1.
interesting, because Marie Curie got 2 Nobel Prizes. I don't know how they felt. I wonder if they met each other. That would be an interesting conversation where Einstein was like, "Hey, so what's up with you getting 2 Nobel Prizes?" No, but that's great. That's a. I like that you used color. By the way, Abdullah, I think you're one of the first to pull out the color there. That is a nice feature. It's all very clear, and it's actually nice, because here's an example where I didn't see the whole presentation, but I just get the whole picture at once. Really nice. Good. And,
yeah, I didn't give any. All of my comments are compliments.
Oh, okay.
So
Come on, you got to give them some constructive criticism.
I don't know.
Sandwich.
Maybe constructive criticism. I would say, if I were to explain the photoelectric effect, maybe showing a curve of like an IV curve and how it was like originally discovered.
Oh, that's what I wrote. I talked over it. Like I wrote down 1800s. That's when they figure out the photovoltaics.
Oh, got it.
It would take a longer time for me to go through that.
Yeah, that's a tough one to cover in 2 minutes.
Yeah,
that's a good. Yeah, but that's good. Yeah, it's very interesting how color is very rarely used, because they, traditionally with chalkboard, we didn't really have color option. right? Of course, you have colored chalk, but it's rare. You just very rarely use. But I know that students actually like it, and especially with online, you know, that you can, with you're using an iPad or something, you know, like this, you can change colors, and it's actually really makes it much more digestible.
Yeah, it's really easy and it's plenty of stuff.
Yeah.
And I
Yeah.
Also with chalkboards. Also with chalkboards, it's hard to see from far away if it's the contrast, if it's not just black and white. So colored chalk was just, if it was a big lecturing hall, it would be hard to see.
That's a good point. What tool, what system are you using to draw this? What is your software?
Notability.
Notability?
Yeah.
So I have Notability, but it doesn't have all those colors.
Oh, you can customize your own colors in Notability too.
Oh, no. If you're updated to the newest one, if you click on this, basically on this, the color things, the pen, and you just slide to the right.
Oh, I never knew I could do that. That's interesting.
And then you can customize whatever you want with if you press this guy, you can go like more in detail.
Oh, yeah, now I see it. Thank you. You just taught me something I never knew about my own Notability system.
And
Okay,
the same thing for the highlight as well. So it's pretty useful.
Oh, you can do that. Oh, very nice.
Hey, Dr. Goldberg, have you tried using the annotate feature on Zoom? Maybe that might like help for future classes, might be easier.
What do you mean?
Like you can, if you go under view options, you can click annotate and you can like draw. Did you see that? Can you see that?
Yeah,
Wait,
I'm
just looking
right now.
Can you see that pink mark I made?
Yeah. I can see it.
Yeah, so like if like Dr. Goldberg, if you share a blank screen, you can just have students annotate over it and draw over it instead of having each student like share their own screen.
Oh.
Yeah.
Wait, now you're saying, can I draw on top of his screen?
Yeah. I think that's how it works because like I've had some meetings where they made us annotate on other people's stuff like that.
But here's the question. So I'm looking now at the screen, but I don't see where I can go in and annotate.
Do you see where the things like where there's the mic and this camera?
Yeah, it's on top, not
Yeah.
it's on top.
Yeah, it's on the part right. There should be annotate near the more, the dots.
Well, I see the more, but I don't. I see reactions.
Okay, then
Breakout
click on more, and you should say annotate in there. If you click on more.
No, it doesn't.
I use the view options.
Oh yeah,
View options in the top middle.
Yep.
I think it's because somebody else is sharing. So
Oh, I see. Yes.
view the options on his pane or reference.
Okay. Fair enough.
So wait, because I still don't see an option for me to draw on your screen.
Because it says you are viewing Abbas's screen.
Yeah, but I can draw.
Yeah,
on
and then besides that, there's view option.
You see view options, the top middle, Professor? On your
I
screen?
see like top middle. View options. Oh, I'm sorry. Yes. Annotate.
There you go.
Yeah.
Okay, I was going into over in the upper left. There's like there's meeting view edit window, and that's what I was looking at. Oh, very nice. Okay.
Yeah, I just thought it might be easier in case you're trying to do something like this in the future, so that not every student has to screen share and take up more time. It just might save you some time.
That's
The
pretty
real MVP.
cool.
Shy.
And then I could
Real
hit
MVP.
eraser, and I could just erase this whole thing. Yeah. Okay. Thanks for teaching me something.
Oh, sorry, I drew on your thing, Abdullah. My bad.
No, thank you. I feel like everyone liking my stuff.
All right, Chai. Thank you for that tip. That's great. I did
All
not know that. Okay, you just taught me something new. Fantastic. Okay, everybody. So, any other quick tips that you want to share with everybody that anybody learned? Abdul, if you could unshare your screen.
I wanted to ask a question.
Yes.
I'm not sure who sort of relates to this, but I feel like, you know, when I was doing my 2-minute lecture, the timing, like, there was something I rehearsed, and then when I was put on the spot, the timing pressure / anxiety just like changed the way I was delivering what I rehearsed. And I don't know, what are just general thoughts on how to deal with that? I feel like when you're in front of a classroom and you're explaining, it's just different than when you practice.
Yeah, no, that's a great question. And actually, That's a great question for presenting in general. And the time goes under this weird shift when you're, standing in front of an audience, because you're, it's pressure, and time tends to either, you generally speed up, but you will find yourself falling behind. So one of the things that is really important to practice is how to adjust and gracefully cut things out if you notice your time going down. And this is a really interesting, we could talk about this for hours. I actually really feel it's important because one of the things that's most uncomfortable is when you see somebody giving a talk and they're really running over, and it makes everybody uncomfortable, and they're taking up somebody else's time, and they're just being rude, So, and then the other thing that's equally uncomfortable is when someone gets cut off, like, sorry, you must stop now, that's awkward. But trying to get them hit it close is very hard to get. No one can get it exact. The challenge is just sort of feeling the vibe, doing some, having a way of looking at a clock so you get a sense of it. And then most importantly, when you look at that clock and you realize you got to wrap it up, finding a way to just like get to the end, right? And having a quick conclusion so that you control it. So it doesn't feel like you get cut off or you're trying to squeeze. Does that make sense?
Yep.
Yeah. So I would say it's called the exit strategy. Okay. So in other words, know where you want to go and make sure you can get there. And that means that you have some last slides. You could just very quickly skip over some slides. Nobody's even going to notice, but know that you want to hit to make sure you get on your last couple slides that are the most important. Okay.
Does that mean? Go ahead, Salim.
One thing I felt during like Blackboard courses was useful was when you have different Blackboards and you can sort of pivot at, like, you finish one board, you move it up, and then you go to the next board, and then you move it up, and then that sort of helps keep track of time. But maybe the analog virtually is not as one-to-one. So I don't know, what would be ways, like maybe in Notability or something, or in any of these tablet apps, you'd like fill up a certain area and then erase it and then go on to a next one, but not real, and then have stopping points.
I'm open to suggestions on that one. I have to tell you, I'm using that for my other class, which is much more of a lecture, and I'm scrolling, and then I have to scroll back, and I don't want to make them seasick, I mean, so I'm like, yeah, you're right. That would actually be really nice as a way of managing the Blackboard and breaking up I have all these suggestions about how to improve Zoom, by the way, but no, I don't have a good answer. I'm trying to learn that. And let's see, who else had a point? I think Preston was about to say something.
Yeah, are you implying that whenever you speak or present, to always kind of have that contingency plan, because things can always go south, and maybe there's a phone distraction, somebody has an emergency, to always know the key points you need to hit before the time is up, and
That's
always
right.
knowing what's critical versus what's just not as critical.
Yeah.
Okay.
I mean, I was on I'll never forget. I'll tell you guys this quick story. We were given an opportunity to have a meeting with Elon Musk. He was curious about when Berkeley AI Research Lab started out. He got wind of it, and his assistant came to me, actually, because we had a mutual friend, and said, Elon wants to know more about this, might be willing to invest. So of course that got our attention, and make a long story short, it took about 2 months to get on his schedule. But we had this meeting at his headquarters on the peninsula. And what happened was all the faculty, so I had 16 faculty, everybody wanted to go, but all the senior faculty, including the dean, were all going down. And I said, let's really make the best use of this time. We have an hour. We sequenced it, so everybody practiced, and we had everybody down to these like great 6-minute talks, and I had all the slides on my laptop, and everything was set, and we were really like, and I made it really clear, don't go over your time, because we only have this much time, and we want to really make a great impression and everything. So we all get down there. We get into this big, beautiful conference room like I've never seen before. It was like had the biggest like projection screen, super ultra high def, and this cool white table. We're all in there. And the assistant came in and said, you know, I'm really sorry, but Mr. Musk is running a little late. He's got something going on, but he'll be here soon. Okay, fine. So, you know, we're all a little nervous, right? And so we're sitting around, making a little joke, small talk, and whatever. Time's ticking by, 15 minutes, comes back in, the assistant comes back and says, you know, he's got something really important that's come up, a bit of a crisis. So he's going to be another, you know, I mean, I just don't know, but he'll get there soon. Okay, literally another half hour. So we're 45 minutes, we're waiting in there. Boom, the door opens and Elon Musk walks in looking really haggard, like he had just been up all night, right? And he's wearing like a t-shirt that's kind of like, he's like sweaty in this t-shirt. And he's like, ah. And it was sort of like, you know, I think he was on the verge of just canceling the meeting, but he felt bad. We're all in the, you know, all these professors are in the room. So he's like, oh, you know, I'm sorry, you know, something's come up. I can't tell you what it is. We later found out it was the day that he had learned about the accident when the Tesla crashed and killed somebody. Remember that story? This was 2 summers ago, 3 summers ago now. Anyway, so obviously he had a lot on his mind. He said, listen, you know, he was so tired, like he just looked really stressed. And he's like, okay, well, and I said, okay, we totally understand. I said, listen, how much time do we have? And he said, well, I hate to say this, but 15 minutes. So I pivoted over to my senior colleagues and the dean, and I was like, all right, everybody, cut your talk down by a factor of 4, okay? So we planned for an hour, do it in 15 minutes, go. And it was a very interesting moment because everybody, you know, had practiced this thing and there was a moment in front of Elon Musk, right? So everybody wanted to say what they wanted to say, but the first one went, you know, over. And I was like, I'm sorry, I got to cut you off. Okay. So that was a little awkward. The second one went and they were a little bit over. And I am like in this terribly stressful position of trying to cut my colleagues off, worrying about keeping Elon Musk, right? So this is a timing nightmare. And one of my colleagues went on and on and on. And he was just lapping up the spotlight. And I literally had to plug, basically like, it was like a hook. I was like, please, I'm sorry, but you have to please sit down. And he looked at me like, he's very senior, by the way, very above me. He was like, oh, you are gonna regret that. That was like the worst. Anyway, what happened was we got through all this and I was watching the clock because we weren't done, but he basically ended up asking questions again and kind of absorbed in what we were talking about and AI and the future. And basically we got the full hour. So it worked out. But I was so stressed. It probably took at least a year off my life, that meeting. But it was a good story and it was very fun to connect with him. And he didn't give us $1 billion that we thought he was going. Anyway, timing is everything, and it does matter, and it's a matter to get it right. And so, you know, it's also impossible to do it perfectly. And so, you know, in the class, it's important to let people off at the right time. I've learned that. I've seen that in my reviews where people are like, kept the class going, ran over. You know, that's not cool. So I'm going to let you all go. I really appreciate you guys staying till the bitter end here of 2 hours. But we will talk about this. This is the kind of thing. And by the way, the last thing I'll leave you with, we're in for a treat next week. I'll send an email out announcing this, but next week we have a guest lecturer who runs the 375 series for the entire campus. Her name is Linda Von On. She is brilliant. She's a teacher's teacher, right? So she is going to come, and her topic is really interesting. It is the transferable skills of teaching. So she is going to, basically the hypothesis I talk about, that what you learn about teaching is going to help you in research, that's what she's going to talk about, okay? So that's the first hour of next week. It's going to be really interesting the way she does it. So looking forward to that. I'll send an email out. Thank you, everybody. Really enjoyed talking to you tonight. Stay healthy, stay well. See you next week.
Thank you.
Thank you.